Hello, and welcome back to Sleepy Science Stories. I'm so glad you're here tonight, wherever you are in this quiet moment. The day is behind you now. The noise, the movement, the lists of things. Undone, they can wait. Right now, there is only stillness and the slow rhythm of your breath. Let the air around you soften. Feel the weight of your body sink gently into rest. Each inhale gathers the remnants of the day. Each exhale releases them into the calm. Outside, the night stretches wide, patient, endless, silent. Above you, stars shimmer like faint echoes of thought. Somewhere, far beyond even their light, space folds into itself, not broken, not empty, but curved, woven, whispering. Two distant points in the universe reach for each other and touch. This is where our story begins, in the hidden folds of spacetime, where distance bends and reality connects upon itself. What if there are secret tunnels in the fabric of the cosmos, shortcuts through time and gravity, doorways that link one star to another, one universe to the next? Physicists call them wormholes, bridges of light and geometry, imagined first by Einstein and dreamed of ever since. They may be mathematical ghosts, or the universe's way of reminding us that separation is never final. So tonight, as you drift deeper into the quiet, we'll follow that idea softly, gently, through theory, history, and imagination. Not to prove, but to wonder. Not to escape, but to rest inside the vastness of what might be. Close your eyes now. Let the stars fade into thought. And together, let's step through the wormhole. A wormhole is a hypothetical tunnel through space-time. In the vast architecture of the universe, physicists have imagined the existence of tunnels, invisible corridors that could link one region of space-time to another. These are not holes in the ordinary sense, but passages within the very fabric of reality. If space-time is the canvas upon which all events unfold, then a wormhole would be a secret fold in that canvas, a hidden thread stitching two distant corners together. Though no telescope has ever glimpsed one, mathematics leaves the door open for their possibility, as if the cosmos itself allows for shortcuts between its endless roads. It connects two distant points in the universe, or perhaps two different universes. A wormhole could act like a bridge not just between stars, but between entirely separate cosmic realms. Imagine a tunnel that begins near our sun and ends in a galaxy billions of light years away, or even in a parallel universe governed by different constants. This concept challenges our sense of distance and boundary. In the ordinary world, light takes eons to cross the gulf between galaxies, but a wormhole would skip that journey, collapsing vastness into intimacy. Whether these bridges exist or not, they reveal how deeply we long to connect what is apart, both in space and in thought. The term wormhole was first used by physicist John Wheeler in 1957. Before the name wormhole, scientists spoke of bridges or tunnels in Einstein's equations. It was John Archibald Wheeler, a brilliant, poetic mind in theoretical physics, who coined the term we now use. He imagined space-time as an apple, and a worm burrowing through it to reach the other side faster than crawling over the surface. The image was vivid, simple, and unforgettable. Through that metaphor, an abstract solution in mathematics became something anyone could picture, a direct path through reality's interior, carved not by creatures, but by gravity itself. Imagine folding a piece of paper, A wormhole is the shortcut between two dots. This image is often used to explain the impossible in the simplest way. Take a flat sheet of paper, mark 2 points on it. In normal space, the shortest distance is a straight line drawn across the surface. But if you fold the paper so the 2 points touch, then pierce through them with a pencil, you've made a wormhole. It's an act of geometry made tangible. The paper is spacetime. The fold is curvature. The hole is connection. What looks like magic is merely a deeper level of geometry, one that nature itself might employ in the hidden dimensions of reality. Einstein and Rosen first proposed it in 1935, calling it an Einstein-Rosen bridge. Long before the name wormhole appeared, Einstein and his collaborator Nathan Rosen found something curious while exploring the equations of general relativity. When they modeled black holes, the mathematics suggested a mirrored region, another universe on the other side. They called this structure the Einstein-Rosen bridge. It was elegant, but fragile. The bridge would collapse before anything could cross. Still, the idea remained. Space-time might contain natural passages that link two regions in a single continuous geometry. Their insight opened one of the most haunting questions in physics. Is the universe connected by unseen bridges? A wormhole isn't a hole in space. It's a bridge within space. When we picture a hole, we often imagine an absence, a void or rupture. But a wormhole is the opposite. It is connection. It doesn't tear space apart. It reshapes it. Inside such a bridge, the familiar rules of direction and distance no longer apply. The concept reminds us that emptiness itself can be structured, that space, though invisible, behaves like a fabric that can twist, stretch, and even knot itself into tunnels. The wormhole, then, is not destruction but architecture, a quiet design hidden within the weave of reality. It curves space-time so deeply that distant places might touch. Gravity is not just a force pulling objects together. It's the curvature of space-time, caused by mass and energy. When that curvature becomes extreme, it can fold distant regions toward each other. In a wormhole, this folding reaches its most dramatic expression, the meeting of two faraway zones in a single continuous geometry. Imagine two galaxies separated by billions of light years. Yet, within the equations, their coordinates might overlap. The wormhole transforms distance into intimacy, showing that even in the vastest universe, closeness may be a matter of perspective. If space were an ocean, a wormhole would be a hidden current between shores. The cosmos is often compared to a sea, vast, fluid, and restless. In that ocean, light itself is like a wave traveling endlessly across the cosmic deep. A wormhole would be a secret current beneath that surface, a flow that carries travelers swiftly from one shore to another. You could spend eternity drifting across open water, or slip into that invisible stream and arrive before the echo of your own wake. Whether it truly exists or not, the image evokes something deeply human, the wish for passage, for an unseen path through impossible distance. No one has ever seen one, yet equations say they could exist. All wormholes live, for now, in mathematics. Theoretical physics provides the canvas, imagination supplies the color. Despite the absence of evidence, the equations of relativity do not forbid their existence. They fit neatly within the laws of gravity. If certain exotic conditions are met, observationally, we search for clues. distortions of light, sudden anomalies near black holes, strange bursts of radiation. None are conclusive, but science often begins this way, with ideas that seem too elegant to ignore. The absence of proof is not proof of absence, only a pause between curiosity and discovery. Wormholes are a solution, not a certainty, in Einstein's equations. When scientists solve Einstein's field equations, they find many possible geometries, like musical variations on a cosmic theme. Some correspond to black holes, some to expanding universes, and a few to wormholes. These are solutions, mathematical possibilities within the grand symphony of relativity. But a solution is not a guarantee of reality. Nature must still choose which notes to play. Wormholes may exist only on paper, beautiful but unplayed. Or perhaps they hum faintly, somewhere in the darkness, awaiting an observer who can finally hear their tune. They could be tiny, quantum-sized tunnels. Not all wormholes need to be cosmic in scale. Some theories propose that countless microscopic wormholes exist at the quantum level, little bridges flickering in and out of existence in what's called the quantum foam. These would be smaller than atoms, smaller even than the Planck length, the smallest unit of measurable space. They might appear for fractions of a second, connecting points infinitesimally apart, though no traveler could fit inside. They suggest that space-time itself is alive with motion, a restless sea of miniature connections forming the foundation of all that exists, or vast enough to swallow a star. At the opposite extreme, wormholes could be immense, cosmic tunnels so wide that entire suns could vanish within them. These might form naturally under extraordinary conditions, perhaps in the aftermath of black hole collisions or near the heart of dying stars. Their throats would shine with warped light, bending and stretching everything around them. A spaceship entering one would witness stars twisting into spirals, time elongating into silence. Such giant structures, if they exist, would reshape how we think about interstellar travel and the ultimate architecture of the universe. Their mouths could appear near black holes. Black holes are natural laboratories for extreme space-time curvature. Some physicists suspect that the gravitational fields around them could hide wormhole entrances. The regions near a black hole's event horizon already warp time and light beyond recognition. A wormhole mouth might mimic such behavior, confusing our instruments. To an observer, it could look like a black hole, yet behave differently. Instead of consuming everything, it might let something through. Whether such black hole mimics exist is unknown, but studying them brings us closer to understanding the geometry of both destruction and passage, or flicker within the quantum foam of the universe. Zoom in far enough, past atoms, past quarks, down to the Planck scale, and space-time ceases to look smooth. It becomes turbulent, frothy, unpredictable. This is the quantum foam, where energy fluctuations constantly reshape geometry. Some physicists imagine wormholes forming and collapsing here continuously, too small and too brief to observe. Though invisible, these microbridges might connect the deepest layers of reality, forming the hidden scaffolding that holds space together. If so, the universe is not static, but alive, breathing through infinitesimal openings, whispering through its own fabric. Travel through one would mean bending not just distance, but time itself. Einstein taught that space and time are inseparable, two aspects of a single continuum. Bend one, and the other bends too. Passing through a wormhole wouldn't only move you elsewhere in space, it might also shift you in time. Step in today, emerge tomorrow, or yesterday. The equations make no distinction. The path through a wormhole curves through spacetime itself, turning here and now into variables, not constants. Such travel, if ever possible, would challenge our entire sense of causality, yet remind us that time itself may be another kind of distance, waiting to be crossed. A wormhole could link the past to the future. If the two mouths of a wormhole experience time differently, say, one remains near a massive star while the other drifts in emptier space, then time dilation could cause them to fall out of sync. Step through one end, and you might arrive at a moment centuries earlier or later. This concept turns the wormhole into a cosmic time machine, not built from metal and gears, but from geometry. Though paradoxes arise, what if you met yourself? The possibility fascinates physicists and philosophers alike. The line between science and imagination grows thin here, illuminated by wonder. Or connect your room to another galaxy in one step. If wormholes were stable and traversable, they could make interstellar travel trivial. Imagine standing in your room, opening a portal that leads not across continents, but across light years. Outside your door could be the blue glow of the Andromeda Galaxy, or the heart of a nebula. Such images populate both dreams and science fiction, but they're rooted in real equations. Relativity doesn't forbid instantaneous travel, it merely demands the right geometry. The thought alone expands our sense of possibility, reminding us that imagination is often the first prototype of discovery. They are the universe's dream of shortcuts. Everywhere in nature, energy seeks the path of least resistance. Rivers carve valleys, light takes straight lines, evolution favors efficiency. A wormhole would be the universe applying that same principle on a cosmic scale, finding the shortest route between distant points in spacetime. It represents an underlying elegance, a yearning for connection built into the laws of reality. Whether or not wormholes truly exist, their concept reflects a deeper truth. The cosmos may not be random chaos, but a system that values harmony, symmetry, and subtlety even in its grandest mysteries. Science calls them speculative. Imagination calls them possible. Within scientific circles, wormholes are treated with caution. They arise from valid mathematics, yet require exotic conditions that no known matter can satisfy. They belong to the edge of theory, beautiful but untested. Still, imagination refuses to dismiss them. Every major discovery in history began as speculation, once dismissed as fantasy. The boundary between science and imagination is porous, and wormholes live precisely at that border. To contemplate them is to stand where knowledge fades into wonder, where logic meets the unknown, and quietly shakes hands with it. Somewhere, spacetime might already be whispering through one. Perhaps, somewhere in the deep cosmos, a natural wormhole hums silently, invisible to our eyes. Steady as a heartbeat of the universe, light bends around it. Gravity flows through it like wind through glass. We might not yet possess the instruments to see it, but reality does not wait for our understanding. The cosmos is vast beyond measure, and mystery is its native language. Maybe one day, far from now, a signal or a beam of light will vanish in one region and reappear in another, and We'll know the whisper was real all along. General relativity describes how mass curves spacetime. Einstein's great insight was that gravity is not a force pulling objects through emptiness. It is the shape of space itself. Every planet, every atom, every photon moves along the curves carved by mass and energy. Where matter gathers, space-time bends inward. Where there is emptiness, it stretches smooth. This curvature tells the moon how to orbit and light how to travel. What seems like attraction is really geometry, the universe folding and guiding everything that exists. A wormhole, then, is geometry taken to its most daring extreme, a bridge built from pure curvature. A wormhole is an extreme form of that curvature. When gravity becomes intense enough, it can twist space-time until two distant regions meet. This is not a tear or break, but a continuous bending, a smooth distortion where the rules of distance dissolve. A wormhole represents the most extreme expression of Einstein's equations, a geometry so deep that space folds back upon itself. The same mathematics that describes orbiting planets can, under the right conditions, describe tunnels between stars. The difference is only degree, a whisper of curvature transformed into a roar. Einstein's field equations allow such bridges under certain conditions. The field equations of general relativity are not merely about planets or black holes. They describe how energy and geometry dance together. Hidden among their countless possible solutions are exotic ones, geometries that curve in ways unfamiliar to daily life. Some of these describe bridges, or throats, that link distant regions of spacetime. The equations don't forbid them. They simply demand precise balance, enough energy to curve space inward, but not so much that it collapses. Within those fragile parameters lies the mathematical possibility of a wormhole, delicate, fleeting, but real on paper. To hold a wormhole open, something exotic is needed. If a wormhole formed naturally, its immense gravity would cause it to snap shut instantly. To prevent this collapse, physicists propose a strange requirement: exotic matter. This substance, unlike anything we know, would have negative energy density. It would push outward instead of pulling inward. In a universe built on attraction, exotic matter would be repulsion embodied. It would act like scaffolding, holding the tunnel open against gravity's relentless grip. Without it, no traveler could pass through before the structure folded in upon itself like a collapsing star. That something is called negative energy or exotic matter. In normal matter, energy is positive. It adds to the mass of the universe, increasing gravitational pull. But in quantum physics, there are strange situations where energy can be negative for brief moments. The Casimir effect, for example, shows this on tiny scales. Two metal plates in a vacuum attract because virtual particles between them carry less energy than the space outside. This negative energy is real, measurable, but fleeting. Theorists imagine scaling this effect up, enough to support a wormhole's throat. It's speculative, but it hints that physics might allow such miracles, however briefly. Negative energy bends space in the opposite direction of normal matter. Where ordinary matter curves space inward, negative energy would push it outward, like inflating rather than compressing the cosmic fabric. In the language of Einstein's equations, the signs reverse. Gravity becomes anti-gravity. This outward curvature is what keeps the wormhole open, balancing the inward pull of mass. The result would be a stable tunnel, neither collapsing nor expanding uncontrollably. It's as if the universe itself must inhale and exhale simultaneously to keep the passage alive. Such symmetry is breathtaking and nearly impossible to create, at least with our current technology. Without it, the tunnel would collapse instantly. If exotic matter were absent, gravity would crush the wormhole's throat faster than light could cross it. In less than a heartbeat, the bridge would vanish, sealed forever by the same curvature that created it. Even light itself could not escape once the collapse began. The equations predict this with merciless precision. Stability is fragile in space-time. The smallest imbalance can turn wonder into implosion. This is why real wormholes, if they exist, might flicker only for fractions of a second, brief cosmic sighs before the universe smooths itself again. The equations suggest that the throat must resist gravitational collapse. The throat of a wormhole, its narrowest point, experiences the most extreme curvature. There, gravity tries to squeeze the tunnel shut, while exotic matter pushes outward to resist it. Mathematically, this balance is expressed through the Einstein tensor and the stress-energy tensor, locked in perfect opposition. The equilibrium must be exact. Even the slightest disturbance would destroy the passage. It's a dance between attraction and repulsion, between geometry and energy, a reminder that in physics, beauty often exists precisely on the edge of instability. The energy density would have to be lower than the vacuum of space. Even empty space isn't truly empty. Quantum fluctuations give it a faint energy called the vacuum energy. To create a wormhole, we'd need matter with less energy than that, effectively below zero. This seems impossible, yet the equations leave a small loophole. Quantum mechanics occasionally allows negative energy for fleeting moments. Harnessing it, however, would require controlling spacetime on subatomic scales, extracting the impossible from the invisible. It's one of those paradoxes where mathematics says yes, but the universe whispers, not yet. This defies all ordinary physics, yet remains mathematically valid. General relativity doesn't promise that every mathematical solution exists in nature, but it refuses to rule them out. Wormholes occupy that strange territory where the equations still work, but common sense fails. No known material can meet their conditions. Yet the math remains consistent and self-contained. It's a humbling reminder that the universe is not obliged to fit our intuition. What we call impossible may simply be undiscovered. The laws of physics are silent about what the cosmos chooses to manifest, and sometimes silence is permission. Kip Thorne's team studied traversable wormholes in the 1980s. In the late 20th century, the idea of wormholes moved from abstract speculation to serious study, thanks to physicist Kip Thorne and his colleagues. They asked a daring question: could a wormhole be traversable, stable enough for a person, or at least a photon, to pass through? Their papers combined rigorous mathematics with imaginative scenarios, exploring how negative energy might stabilize such structures. What began as a thought experiment soon became a cornerstone of modern gravitational research, and even inspired the physics behind Hollywood's most realistic portrayals of space travel. They wanted to know, could humans ever travel through? The question was more than academic curiosity. It was a test of physics boundaries. If the equations of relativity allowed wormholes, could a sufficiently advanced civilization build or use one? Thorne's team calculated the stresses, radiation, and tidal forces a traveler would face. The results were grim. Without exotic matter and precision control, any attempt would be fatal. Yet the exercise illuminated the edges of possibility, showing that while nature guards her shortcuts, she doesn't lock the door entirely. Curiosity itself became the first step through their answer, only with technology far beyond ours. The energy required to create or stabilize a wormhole would dwarf the output of stars. Even generating a speck of negative energy on macroscopic scales lies far beyond human ability. The forces involved would tear apart any spacecraft, any planet, any hope of survival, at least with today's understanding. Still, physics doesn't forbid future breakthroughs. Just as early humans once looked at the sky and thought flight was impossible, perhaps someday we'll learn to sculpt spacetime as easily as we now shape metal and light. The structure must be perfectly stable, a cosmic balancing act. A traversable wormhole would need equilibrium so exact that even the quantum tremors of space could destabilize it. The stresses inside would be immense, yet must cancel out precisely. Too much energy, and the tunnel collapses. Too little, and it evaporates. It's the ultimate tightrope, geometry balancing on the edge of its own collapse. The comparison to an arch of stone is fitting. Gravity both threatens and supports it. But here, the stones are made of space-time itself, held in tension by the invisible hands of mathematics. Even small perturbations could destroy it. Like a soap bubble trembling in air, a wormhole's stability would depend on stillness. A single photon entering too fast, a fluctuation of vacuum energy, even a passing gravitational wave could trigger collapse. The bridge might disintegrate before its traveler reached halfway. In physics, such sensitivity is both curse and beauty. The reminder that the most delicate structures often embody the deepest elegance. If wormholes exist, they may live brief, shimmering lives, flashes of connection across eternity, appearing and fading faster than thought. Quantum effects might destabilize the tunnel. At microscopic scales, uncertainty reigns. Energy fluctuates, particles appear and vanish, and space-time ripples unpredictably. These quantum tremors could accumulate within a wormhole, amplifying until the geometry itself buckles. The same quantum mechanics that might create wormholes at tiny scales could also destroy them at large ones. The universe seems to permit the idea, but punishes the attempt. Still, studying this tension between relativity and quantum theory guides modern physics toward its greatest goal, a unified understanding of everything, from the smallest to the infinite. Gravity waves might ripple through it unpredictably. Wormholes, if they existed, would not be isolated from the cosmic sea. Gravitational waves, the ripples in space-time caused by massive events like merging black holes, could pass through or around them, distorting their shape. A strong wave might collapse a fragile tunnel or scatter its entrance across dimensions. Yet, if we could detect such disturbances, they might reveal wormholes indirectly. Tiny, repeating anomalies in the wave's signature, hints of hidden geometry echoing through the dark. Even instability leaves traces for the patient observer. But in theory, such a bridge could exist for microseconds or eternities. The lifespan of a wormhole depends entirely on its internal balance. Some models suggest they would blink into and out of existence faster than any instrument could detect. Others allow for long-lived, even permanent, tunnels if the right conditions hold. In an infinite universe, both may occur. Somewhere, fleeting wormholes may flare and fade like cosmic lightning, while others endure for eons, unnoticed in the black between galaxies. Time itself becomes part of the experiment, the geometry deciding how long it wishes to remain open. The math does not forbid beauty. Amid the dense equations of relativity, something poetic emerges. The same symbols that predict the orbit of Mercury or the bending of starlight also describe gateways across space and time. Mathematics, in this context, becomes a kind of art, a way for the human mind to touch the structure of the universe without leaving Earth. Whether wormholes exist or not, their equations remind us that reason and wonder are not opposites. They are two halves of the same curve, meeting somewhere beyond the horizon of understanding. It only asks for courage to imagine. Physics, at its heart, is an act of imagination disciplined by truth. Einstein once said that imagination is more important than knowledge, because knowledge is limited to what we know now. To picture a bridge through space-time is to practice that courage, to explore what the universe might allow even if we never see it. Every breakthrough begins this way. A thought, a sketch, a quiet defiance of the ordinary. Wormholes remind us that curiosity itself is the first traversal, the mind's own journey through the folds of the unknown. Einstein and Rosen built the first mathematical model. In 1935, Albert Einstein and his collaborator Nathan Rosen were exploring the strange geometry of black holes when they discovered something unexpected, a bridge, hidden in the mathematics. It connected two distant solutions of Einstein's equations, forming a continuous passage through space-time. They didn't call it a wormhole, they called it a bridge. To them, it was an elegant curiosity, a reflection of how relativity allowed the universe to bend upon itself. Little did they know that their paper would open a doorway not just in physics, but in imagination, one that would never truly close. Their bridge connected two black holes back to back. The Einstein-Rosen bridge, as it became known, described a geometry where two black holes were joined at their singularities, mirror images touching at a single point. Matter entering one side would seem to reappear from the other. But there was a problem. The bridge was purely theoretical and existed only for an instant before collapsing. It was like a cosmic soap bubble, beautiful, fleeting, gone. Still, it was enough to ignite a spark in generations of physicists who wondered whether nature might one day find a way to hold that bubble open. But it wasn't traversable. It pinched shut too quickly. Einstein and Rosen's equations predicted that the passage between the two black holes would collapse faster than light could travel through it. Any object entering would be crushed long before reaching the other side. The geometry itself conspired against travel. The bridge, elegant on paper, was merciless in reality. Yet even in that impossibility lay a strange beauty, the hint that space-time had the capacity for connection, even if it was short-lived. The first bridges may have been closed, but they showed us where to start building. Later theories explored how to keep it open. In the decades that followed, physicists began to ask a bold question. What if we could prevent the bridge from collapsing? Could negative energy or exotic matter act as a scaffold to hold space-time apart? New solutions appeared, each more daring than the last. Traversable wormholes, time-shifted tunnels, even connections between parallel universes. Most of these ideas lived only in equations, but that was enough. Science progresses not just by what is proven, but by what can be imagined within the rules of truth. The idea fascinated physicists and storytellers alike. By the mid-20th century, wormholes had become more than a scientific curiosity. They were symbols of possibility. For physicists, they represented the frontier of geometry. For writers, they were metaphors for hope, escape, and discovery. The concept appeared in books, films, and dreams, carrying with it both realism and wonder. Science and art rarely travel together, but here they met in the same tunnel. The human desire to transcend distance, to see what lies beyond. In the 1960s, John Wheeler gave them the name wormholes. It was John Archibald Wheeler, Einstein's student and one of the century's great scientific poets, who finally gave the bridge its modern name. He imagined spacetime as an apple, and a worm tunneling through it to reach the opposite side faster than crawling over the surface. The term wormhole captured everything. The simplicity of the image, the strangeness of the idea, the mystery of unseen paths. With one metaphor, Wheeler transformed a mathematical curiosity into a concept that anyone could visualize, even dream about. Science fiction soon took the idea further. Once the word entered popular consciousness, wormholes escaped the confines of academia. Writers and filmmakers saw in them a perfect stage for imagination, instant travel, time loops, alternate realities. From pulp magazines to cinematic masterpieces, the wormhole became a symbol of both technology and transcendence. While scientists debated equations, storytellers asked how it would feel. The awe, the disorientation, the quiet terror of stepping into the unknown. Fiction gave emotion to what physics could only describe. Movies like Interstellar used real physics as inspiration. When Interstellar reached the screen in 2014, audiences saw perhaps the most scientifically faithful depiction of a wormhole ever created. Director Christopher Nolan wanted authenticity, so he turned to physics itself. The shimmering sphere that appeared above Saturn wasn't a fantasy. It was rendered using Einstein's equations. Viewers watched space bend around the wormhole exactly as relativity predicted. What began as a work of imagination became, in a sense, an experiment, a visualization of equations too vast to fit on. A blackboard, translated into light and motion. Kip Thorne himself advised on the film's visuals. Behind the scenes, physicist Kip Thorne, one of the world's leading experts on relativity, served as scientific consultant. He provided real equations describing how light would behave near a wormhole. The film's visual effects team used those formulas to render the phenomenon accurately, frame by frame. The result was not only cinematic beauty, but genuine science. In fact, Thorne later published a research paper based on the new insights gained from the visualization process, proving that art can sometimes lead science forward. The wormhole in the movie was rendered with real equations. Every shimmer, every distortion seen on screen was the product of computation, not imagination alone. The light bending around the wormhole followed geodesics, the paths dictated by Einstein's spacetime geometry. The result was mesmerizing, a mirror-smooth sphere that bent the stars around it like liquid glass. Audiences were seeing mathematics made visible, equations turned to vision. The boundary between theory and art dissolved, leaving only awe, a glimpse of what the universe might truly look like if such a gateway existed. Carl Sagan once asked Thorne for help with a story, Contact. Before Interstellar, there was Contact. In the 1980s, astronomer and author Carl Sagan was writing a novel about humanity's first meeting with extraterrestrial intelligence. He wanted the story to be grounded in real physics. So he called Kip Thorne, asking how his characters might travel across light years without violating relativity. Thorne, intrigued, took up the challenge. The result was a scientific model that not only served Sagan's story, but also reshaped modern physics, turning fiction's need into theory's inspiration. He wanted a believable way to travel faster than light. Sagan knew that faster-than-light travel breaks the laws of relativity, but storytelling demands possibility, not certainty. Thorne realized that wormholes offered a loophole. They didn't move faster than light. They simply connected distant points directly. Nothing violated physics. Space itself was redefined. That elegant workaround satisfied both science and story, proving that imagination, when paired with understanding, can reveal paths that neither could find alone. In this way, a novelist's curiosity gave birth to a physicist's paper. Thorne suggested, use a wormhole. From that suggestion, Sagan's fictional journey was born, a human traveling through a cosmic bridge, emerging near another star in moments. What began as literary advice became a cornerstone of theoretical physics. Thorne's work on Contact explored how negative energy could hold a wormhole open, and his calculations soon appeared in peer-reviewed journals. The exchange between writer and scientist became a modern parable, curiosity crossing disciplines, like light passing through a tunnel of shared wonder. Thus, fiction and physics shook hands. Rarely in history have science and art collaborated so harmoniously. Contact showed that storytelling could demand scientific rigor, and science could answer with elegance. The novel and its later film adaptation brought wormholes from the chalkboard into the human heart, symbols not just of travel, but of faith, discovery, and longing. Between the precision of numbers and the poetry of meaning, a bridge formed, as if the idea itself were enacting what it described. The term bridge became a metaphor for hope. The Einstein Rosen bridge was born from mathematics, but the word bridge carries emotional weight. It means connection between places, between minds, between times. Humanity has always built bridges, over rivers, between nations, across silence. The wormhole is the ultimate bridge, imagined not from stone or steel, but from the structure of the universe itself. In that vision, we see ourselves, builders of connections, seekers of what lies on the other side of mystery, for curiosity that refuses to stop at the edge of knowledge. Every scientific revolution begins with a refusal, a quiet insistence that there must be more. Einstein once said he wanted to know how God created the world, meaning how reality truly works beneath its appearances. The wormhole embodies that spirit. It is curiosity refusing to stop at the event horizon, the limit of known physics. It is the question turned into geometry, the dream turned into math. Every equation that follows is a continuation of that same restless wonder. Even Hawking explored their quantum implications. Stephen Hawking, ever drawn to paradox, examined what wormholes might mean for quantum physics. Could they allow information to escape black holes? Could they create shortcuts for particles or perhaps entire universes? He proposed that quantum fluctuations might spawn countless tiny wormholes, fleeting connections between regions of spacetime. Though he treated them as mathematical curiosities, the idea shaped later theories of quantum gravity, blending relativity's smooth curves with quantum theory's restless waves. Could tiny wormholes flicker in quantum spacetime? At the smallest scales, spacetime is not smooth but foamy, a storm of virtual particles and fluctuations. Some physicists believe that miniature wormholes constantly form and vanish in this quantum foam, like bubbles in boiling water. They might last for unimaginably brief moments, far too fast to detect, yet their presence could influence how particles interact. These quantum wormholes might explain why the vacuum isn't empty at all, but alive with hidden connections. If true, the universe hums with unseen bridges, everywhere and always. Some say they might explain entanglement itself. Quantum entanglement, the eerie link between particles that remain connected across vast distances, has puzzled scientists for a century. In 2013, physicists proposed a bold idea. Perhaps entangled particles are connected by microscopic wormholes. When one particle is affected, the change travels instantly through this hidden tunnel, preserving relativity while explaining the connection. The concept bridges two of physics' greatest mysteries: geometry and information. If spacetime itself underlies entanglement, then reality might be woven from the same threads as thought. The idea that wormholes and quantum links are one and the same. This elegant equation, proposed by Meldacena and Susskind, unites two acronyms, ER for Einstein, Rosen wormholes, and EPR for Einstein, Podolsky, Rosen entanglement. Together, they suggest that every quantum link, every act of entanglement, is a tiny wormhole in disguise. Geometry becomes information. Information becomes geometry. The universe, in this view, is a network of connections, not a collection of isolated points. Perhaps every atom, every photon, every thought is already crossing a wormhole, a reminder that separation is an illusion, and that everything is, at its core, connected. In the quantum realm, spacetime is not smooth. To the naked eye, space seems calm and continuous, a silent void. But deep beneath that illusion, at scales trillions of times smaller than an atom, spacetime is restless. It shivers with fluctuations, surges with invisible motion. The laws that govern planets and stars begin to blur here, replaced by uncertainty and probability. The quantum realm is not a stable canvas, but a storm, a sea of flickering energy where geometry itself trembles. And within that tremor, physicists suspect, might lie the smallest and most mysterious wormholes of all. It foams, fluctuates, ripples. John Wheeler, who once named the wormhole, also coined another phrase, quantum foam. He imagined spacetime not as a still ocean, but as a surface of boiling bubbles, each a brief fluctuation of geometry. On that scale, even the concept of before and after loses meaning. Space might briefly fold, connect, or vanish. The foam is not chaos, but potential. Every bubble a miniature experiment in creation. Somewhere in that quantum surf, bridges may appear, connect, and disappear again, unnoticed by the vast, slow world above. Tiny wormholes could appear and vanish constantly. If space-time truly foams, then miniature wormholes might form spontaneously within it. They'd be smaller than any particle, existing for less than a heartbeat of Planck time. roughly 10 superscript 3 seconds. They'd open, connect 2 points, and collapse again before anything could pass through. Yet in their brief lives, they would change everything. They would mean that connectivity is fundamental, that even emptiness is laced with invisible threads. The universe would no longer be built from isolated points, but from fleeting bridges, eternally forming and dissolving in silence. These are called quantum foam wormholes. Physicists use this term to describe those hypothetical microtunnels woven through the vacuum. They're not stable, not traversable, and certainly not visible. But mathematically, they fit within the framework of quantum gravity, a theory that tries to merge Einstein's smooth spacetime with the jittering world of quantum mechanics. If real, quantum foam wormholes might help explain phenomena like entanglement, vacuum energy, and perhaps even the birth of entire universes. They are, in essence, the whisper of geometry at its smallest and most mysterious scale. They may exist at the Planck scale, unimaginably small. The Planck scale marks the frontier of the knowable. Distances of 10 superscript 3 meters, where our physics dissolves. At that level, every concept, length, mass, time, becomes uncertain. A wormhole existing there would be smaller than any particle we can imagine, a fluctuation within a fluctuation. It would not be an object, but a momentary possibility, a pulse of curvature in space-time's deepest fabric. To study such scales would require energies beyond any star, meaning, for now, they exist only as mathematics and metaphor. Perhaps they connect points separated by trillionths of a proton's width. To picture such distances is to confront the limits of comprehension. A proton itself is already almost inconceivably small, yet a quantum wormhole might span a distance smaller still by trillions of times. It would be like folding a mountain into a grain of dust, then folding that dust again into an atom. These tunnels, if they exist, connect regions of space so close together that they might as well be touching, yet their connection could ripple outward, subtly influencing everything built upon them. The smallest bridges may shape the largest realities. These tunnels might carry virtual particles through time. Quantum theory tells us that particles constantly pop in and out of existence, virtual entities borrowing energy from the vacuum before returning it. If micro-wormholes exist, they might be the hidden pathways through which these particles travel, slipping momentarily across time itself. A virtual particle could emerge from one mouth and vanish into another, completing a loop so tiny it exists outside conventional time. In this view, the vacuum is not empty but alive, a dynamic system where energy dances through tiny tunnels of possibility. They might explain why the vacuum is never truly empty. Even in the darkest void, energy hums. The vacuum itself has structure, filled with fluctuations that can be measured through phenomena like the Casimir effect. Quantum wormholes could be part of that structure, acting as conduits that constantly exchange energy and information across spacetime. They might even help stabilize the universe's expansion, balancing positive and negative energies in a delicate equilibrium. The nothingness we see between stars may actually be a vast network of microscopic bridges, alive with silent motion and hidden communication. Quantum gravity seeks to unify these mysteries. Einstein's relativity describes the large, stars, planets, the shape of the cosmos. Quantum mechanics describes the small, atoms, particles, probability. Between them lies a chasm, two worlds that refuse to merge. Quantum gravity is the attempt to build a bridge between those worlds. In that effort, wormholes become natural candidates, connecting not just places but theories. They represent the ultimate synthesis, curvature and uncertainty, geometry and chance, merged into one coherent language. The search for quantum gravity is, in a sense, the search for the universe's hidden grammar. String theory adds extra dimensions that could host such tunnels. According to string theory, the universe may have not just 4 dimensions, but 10 or 11. Most of these are curled up, compact, invisible. In those unseen dimensions, geometry can take strange forms, loops, membranes, and tunnels far smaller than atoms. Wormholes might weave through these hidden directions, connecting points not in visible space, but in the deeper, multidimensional fabric beneath it. We cannot yet look there directly, but mathematics paints a vivid picture. Reality as a vast cathedral of geometry, each archway a wormhole connecting unseen rooms. Maybe wormholes are shortcuts through higher dimensional space. If we imagine the universe as a three-dimensional surface embedded in a higher dimensional reality, then a wormhole could simply be a shortcut through that unseen space. Just as a tunnel through a mountain saves a traveler from climbing over it, a wormhole cuts through spacetime's higher dimension, linking distant points instantly. To us, it appears miraculous. To the higher dimension, it's merely geometry. The idea suggests that what feels like impossibility may just be ignorance of the directions we cannot yet see. We see only their shadows in our 4D world. Just as a three-dimensional object casts a two-dimensional shadow, higher dimensional structures might cast lower dimensional traces into our universe. A wormhole existing in 5 or 6 dimensions might appear to us as a distorted gravitational field, a strange lensing effect, or a ripple in space-time we can't quite explain. The cosmos could be full of such shadows, evidence of geometry beyond our perception. We, the observers, might be the flat figures in a deeper realm, glimpsing only faint outlines of the true architecture around us. Some models predict baby universes budding off from wormholes. Certain cosmological theories suggest that wormholes could give birth to entirely new universes. A fluctuation in the quantum vacuum might create a tunnel that expands internally, growing into a separate cosmos sealed off from ours. From our side, it would look like a disappearing bubble. From within, it would be an entire universe with its own stars, galaxies, and laws. Perhaps our own universe began this way, a wormhole sprouting from another, older reality. Creation, in this sense, could be an infinite recursion of bridges becoming worlds. Others see them as information bridges. Between black holes, once thought to erase all information, may instead store it, or send it elsewhere. Some physicists propose that 2 entangled black holes could be connected by a wormhole. When one consumes matter, the information might pass through the tunnel and re-emerge from the other. This idea not only resolves paradoxes, but ties together gravity, quantum theory, and information science. A black hole, then, would not be a prison but a portal, a boundary that hides communication rather than destruction. The physics of ER equals EPR links entanglement and geometry. In 2013, theorists Juan Meldacena and Leonard Susskind proposed that wormholes, ER, and quantum entanglement, EPR, are two expressions of the same phenomenon. In their model, the threads of entanglement literally are the geometric connections of spacetime. The structure of the universe becomes a network of links, quantum bonds weaving the tapestry of reality. This was a profound shift. Gravity and information were no longer separate topics, but reflections of one another. The cosmos, it seemed, was made not just of matter, but of connection itself. Underscore. Perhaps every quantum connection is a tiny wormhole. If the ER equals EPR idea is true, then every pair of entangled particles might be joined by a microscopic wormhole. Each connection would be unimaginably small, invisible, and instantaneous. Together, these quantum tunnels would form a vast web binding the universe together. What looks like empty space would actually be a lattice of communication where particles speak to one another across invisible bridges. The wormhole, once imagined as a grand cosmic tunnel, might instead be the quiet heartbeat of all quantum existence. That would mean reality itself is woven by invisible bridges. Under this view, space is not an empty stage, but a fabric stitched from relationships. The distance between things is defined not by separation, but by the strength of their connection. Wormholes, then, are not exceptions, they are the rule. They are the threads holding existence. Together, the silent architecture of continuity. The cosmos becomes not a collection of isolated objects, but a single organism, each part aware of the rest through invisible geometry. Connection replaces emptiness as the universe's fundamental truth. Each photon, each atom, connected to all others. Every particle of light that has ever existed may be part of this universal network. A web in which nothing truly stands alone. When a photon travels through space, it might pass across countless hidden tunnels, carrying subtle echoes of everything else. Every atom in your body, every star in the sky, may be linked through this quiet geometry. The idea blurs the boundary between here and there. To exist may simply mean to participate, to be a node in an infinite pattern of connection. Space-time would no longer be distance, but relationship. If entanglement truly builds space-time, then distance loses its traditional meaning. 2 points are far only if their connection is weak. Geometry itself becomes an expression of communication. Where information flows freely, space feels close. Where it falters, space stretches wide. The universe, in this light, is relational, its structure defined not by coordinates, but by conversation. Everything becomes part of a single, ongoing dialogue. Gravity speaking to quantum fields, particles whispering across time. The universe, a web of connected dreams. In the end, the image of wormholes, from cosmic tunnels to quantum threads, reveals a deeper metaphor. The universe is not a scattered collection of stars, but an intricate web of dreams, each touching the next. Every law of physics, every heartbeat, every photon is part of that same continuum. Perhaps reality is connection dreaming of itself, a network of bridges through which thought, matter, and time endlessly flow. And in that web, each of us is both traveler and thread, quietly woven into the fabric of the infinite. Imagine standing at the mouth of a wormhole. You are weightless, suspended at the edge of something no human has ever seen. A sphere of distorted light hovering in the black. Around it, stars twist like reflections on water. Ahead of you, space appears to fold inward, as though the night itself is inhaling. The mouth of the wormhole glows faintly, not with color, but with geometry, a shimmer of bending starlight. It feels less like a place and more like a thought made visible. Behind you is the known universe. Before you, the unknown invites. The stars stretch, light bends. As you draw closer, everything elongates. The constellations you once recognized melt into arcs. Their light wraps around the sphere, spiraling toward the tunnel's center like ribbons pulled into a drain. Colors bleed into each other, gold to crimson, white to blue, until the sky itself seems liquid. Your sense of direction falters. There is no up, no down, only curvature. Time feels slower here. Heavy. You realize you are seeing gravity made visible, the warping of reality itself, the universe flexing its quiet muscle. Gravity distorts your sense of direction. Gravity, near the mouth, behaves like a trickster. It doesn't pull you down, but inward, toward a point that doesn't exist in ordinary space. Your body doesn't fall. It leans, like light bending around a massive star. Even your thoughts seem drawn toward the tunnel, pulled by a curiosity older than fear. The instruments around you fail, their readings looping, trembling. You try to orient yourself, but orientation has lost meaning. The horizon has folded into itself. The compass points everywhere at once. You step forward, and reality folds. Crossing the boundary is not motion as you know it. It feels like slipping between moments rather than places. The space ahead doesn't open. It unfolds, revealing more of itself the further you go. The light from behind stretches endlessly forward, chasing you into the curve. You feel both acceleration and stillness, as if your body moves, but your soul remains. Every law you once trusted bends quietly around you. Inside the wormhole, travel is not distance, it's transformation. Inside, time no longer flows straight. In ordinary space, time runs like a river, forward, steady, inevitable. Inside the wormhole, it spirals. Seconds stretch into minutes. Minutes compress into heartbeats. You glance at your clock and realize it no longer measures anything meaningful. Each tick feels both immediate and infinite. If you dropped a ball, it might fall upward. If you blinked, the light might freeze midair. You are adrift in time's whirlpool, where the direction of before and after becomes a matter of perception, not physics. Every second could equal years elsewhere. Your ship's computer struggles to keep track. Its internal clock diverges wildly from those outside. One moment for you could be a decade to someone waiting on the other side. Gravitational time dilation, the slowing of time in intense gravity, reaches its ultimate form here. The wormhole doesn't merely connect space. It distorts time. You are both traveler and timekeeper, crossing not just distance but centuries. The realization is humbling. To move through the universe is also to move through eternity. You might emerge light years away. At last, the tunnel widens. A surge of brightness floods your vision, like dawn breaking after endless night. The walls of curved light fade, and suddenly, silence. Outside the window, an unfamiliar sky. New constellations, strange hues, a different rhythm to the stars. You've arrived somewhere else, perhaps another arm of the galaxy, perhaps another universe entirely. What was a concept in a textbook is now a horizon before your eyes. Travel, it turns out, is not the act of moving, but of becoming someone who has crossed, or moments before you entered. Yet time's loops are unpredictable. It is possible, at least in theory, that you emerge before you even began the journey. Your ship, perhaps, still hovering near. The first mouth, waiting for the signal that you have not yet sent. To outside observers, paradoxes bloom. Messages arriving before they're sent, shadows cast before the object appears. Inside the wormhole, cause and effect become entangled, not broken, but braided. You are both traveler and echo, exploring not just where you go, but when you are. A wormhole could be both a bridge and a mirror. It connects 2 points, but it also reflects them. As you pass through, the tunnel mirrors your path in subtle ways. Light wrapping around to meet itself, perspectives reversing. It's as though the universe is watching you from both ends at once. The bridge becomes self-aware, a structure that contains its traveler within its reflection. You begin to wonder if every crossing changes not just where you are, but what you are. Perhaps the wormhole doesn't just bend space, it bends identity. What you see might depend on who is watching. In relativity, every observer has their own version of reality, each frame of reference equally valid. Inside the wormhole, this principle becomes palpable. 2 travelers entering from opposite sides might witness completely different worlds. One could see swirling colors, the other perfect darkness. What is real depends on where you stand, or perhaps on what you believe. The wormhole, in this way, becomes a mirror for consciousness, a reminder that perception is always a local event in a vast and shifting cosmos. Light would spiral through the tunnel. Photons entering the wormhole wouldn't move in straight lines. They'd swirl around the throat like ribbons of glass in a vortex, tracing luminous spirals that converge and vanish. Some beams might loop endlessly inside, circling forever, trapped by curvature. To an outside observer, the tunnel would gleam with this captured light, a luminous halo marking the boundary of the impossible. If you could see all the paths at once, it would resemble a cosmic whirlpool, light chasing its own tail across the geometry of dreams. Colors would shift, blues stretching to reds. As you travel deeper, light itself begins to change. The wavelengths stretch, then compress, painting the tunnel with shifting hues. Blue fades to indigo, indigo to crimson, crimson to gold. It's the Doppler effect turned cosmic, time and motion sculpting color. To your eyes, it's as though the tunnel breathes with light, inhaling and exhaling in rhythm with your heart. You begin to lose track of what is color and what is time, both becoming part of the same vast spectrum of motion. Space could feel infinite, yet claustrophobic. The paradox of the wormhole is sensation itself. You are enclosed, yet surrounded by infinity. The tunnel has no walls, only gradients of curvature, yet you feel confined within its embrace. The more you move, the less distance seems to change. You could travel for minutes or centuries. The sense of there never approaches. It's a strange serenity, like floating inside an endless dream. Fear fades into curiosity, curiosity into calm. You realize the tunnel is not imprisoning you. It's teaching you to let go of direction. You wouldn't see walls, only geometry. The interior of a wormhole isn't made of matter. it's made of shape. You don't see texture or surface, only gradients of bending space. It's like being inside a mathematical equation rendered visible. Lines curve into arcs, arcs into spirals, until orientation dissolves into symmetry. Light doesn't illuminate the space. It is the space. You understand, for a fleeting moment, that geometry itself is the universe's language, and you are reading it from within the sentence. The throat could shimmer like liquid glass. At the center, the curvature becomes almost tangible. The air, if such a word still applies, ripples like transparent water. The stars behind you fracture into streaks of light, reflected on invisible walls. The entire tunnel gleams as if made of flowing glass, flexing but never breaking. You feel suspended in beauty that has no edges. The shimmer isn't random, it follows a rhythm, a pulse that might be the universe's heartbeat. For a moment, you sense that even space itself is alive. Perhaps you'd glimpse other travelers, echoes of yourself. Light loops within the wormhole, bending back on itself. In that swirl, you might see reflections, not mirrors, but echoes, of your own image arriving from other trajectories. They move as you move, but slightly delayed, like a memory replayed from another angle. Are they illusions, or real versions of you taking slightly different paths through time? Inside a wormhole, such distinctions blur. Every reflection could be a possibility, every traveler a thought crossing the same timeless bridge from a different when. It's a place where cause and effect dance. Here, nothing happens in a strict sequence. Events weave around one another, forming loops instead of lines. You might throw a coin forward and watch it curve back toward your hand, not because it reversed, but because the tunnel itself folded its trajectory. Physics becomes choreography, gravity, light, and motion moving in patterns too intricate to predict. Cause and effect don't vanish. They begin to dance, each taking turns, leading the other. In that rhythm, time itself seems to smile, and where here and there lose meaning. You realize, after a while, that the concept of location has dissolved. You are no longer in one place or another. You simply are. The tunnel doesn't connect 2 points. It reveals that points were an illusion all along. Here and there become one continuous experience, like opposite notes in the same chord. The wormhole isn't a bridge across distance, but a reminder that distance never truly existed. Only relationships did. You exhale, and the entire universe seems to breathe with you. In theory, travel could take seconds. If a wormhole could remain stable, the journey might seem instantaneous. You'd step in and step out before a heartbeat passes. Yet to outside observers, your trip might appear to last years, centuries, or even longer. The contradiction isn't paradox, it's relativity. Time stretches differently for every observer, every path. What feels like a blink to you could be eternity to someone watching from afar. The wormhole doesn't cheat time. It simply lets you move along its hidden dimension. Yet you'd return centuries later. When you finally emerge, the stars might have drifted into new constellations. The Earth, if you could find it, may have changed beyond recognition. Its continents shifted, its languages evolved. You'd be a traveler out of time, returning to a future that has forgotten your departure. Yet the feeling isn't sorrow, it's wonder. The wormhole has shown you that time is both journey and home, that every ending is a new entrance, and every return is just another step through the infinite throat of being. A wormhole could, in theory, allow time travel. The moment we realize that a wormhole connects not just two places, but 2 points in space-time, the question becomes inevitable. Could it be used to move through time? The equations of relativity whisper a cautious yes. Time is not separate from space. Bend one, and the other bends too. If the two mouths of a wormhole exist in different temporal frames, then entering one could mean exiting at another when, not just another where. The tunnel becomes more than a bridge. It becomes a timeline folded upon itself. If one mouth moves differently through time than the other, imagine two openings of the same wormhole, one resting quietly near Earth, the other aboard a spaceship traveling close to the speed of light. Due to time dilation, one of Einstein's most astonishing predictions, the moving end, would experience time more slowly. When the ship returns, less time has passed for it than for its twin on Earth. Yet the wormhole still connects them. Step through the stationary mouth, and you could emerge in the past or future relative to your own timeline. The tunnel doesn't defy time. It uses its flexibility. Relativity permits such differences. Einstein's theory of relativity is not only about speed, it is about perspective. Time is not absolute, but relative to motion and gravity. Two observers can live through different durations and both be correct. A wormhole simply magnifies this truth by moving its mouths differently, orbiting one near a massive star, accelerating the other. We could create a time offset between them. The fabric of space-time doesn't break. It stretches, patiently accommodating the contradiction. Time travel, in this sense, is not forbidden. It is geometry misunderstood. One end could orbit near a black hole. Near a black hole, gravity is so intense that time slows dramatically. A single hour spent there could equal years elsewhere. If one mouth of a wormhole hovered near that gravitational field while the other remained in open space, their internal clocks would fall out of sync. The wormhole becomes a bridge between two different rates of time. Enter one mouth and emerge from the other, and you've crossed a temporal gulf as real as any distance in space. The deeper the gravity, the longer the leap through time. Time slows there, the other mouth races ahead. The two mouths age differently. The end near the black hole lingers in slow motion, while the distant one drifts ahead into the future. From the perspective of the traveler, nothing unusual happens. You walk through and step out. But to the rest of the universe, you've leapt across centuries. The wormhole acts like a cosmic time lens, focusing the uneven flow of duration into a single, seamless passage. Inside, the laws remain intact. It's only our intuition that breaks. Entering one might lead to your own past. The strangest possibility arises when the moving mouth returns to its origin. The two ends are now separated not just in space but in time. Travel through one, and you could arrive before your departure. The tunnel, once imagined as a shortcut across galaxies, becomes a doorway to yesterday. If you stepped through, you might see yourself from the outside, a figure still preparing to enter. The geometry allows it, the mind resists it. The paradox begins to stir. The equations allow it, though paradoxes remain. Relativity itself doesn't forbid loops in time. The math works cleanly. The trouble lies not in equations, but in consequences. If you could visit your past, could you alter it? What happens to cause and effect if the effect arrives first? Such paradoxes haunt philosophers and physicists alike. The universe, it seems, permits the possibility but guards the coherence. Somewhere between what is allowed and what makes sense lies the mystery of time itself. Could you meet yourself? It's one of the oldest thought experiments. The traveler returning to meet their younger self. Would that meeting be real, or a feedback loop of the same consciousness observing itself from two angles of time? Physics offers no clear answer. In a universe where time is a dimension like space, there's nothing logically impossible about coexisting with your past self. The real question isn't whether you can, but whether reality, in its quiet wisdom, would let you. Could you change history? The classic paradox follows. If you altered the past, even slightly, would the future collapse? Could you erase the very reason you traveled at all? Some theories suggest that time protects itself. Through consistency, that events adjust subtly to preserve the timeline. Others imagine multiple branches, each change birthing a new universe. In either case, time travel forces us to confront a deeper truth. History may not be a line, but a tapestry where every thread already weaves around every choice ever made. Stephen Hawking proposed chronology protection. Faced with these paradoxes, Stephen Hawking offered a simple, elegant idea. Perhaps the universe has a built-in safeguard, a law that prevents time loops. He called it the chronology protection conjecture. According to Hawking, quantum effects would become infinite at the moment a time machine was about to form, destroying it before any paradox could arise. In other words, the universe might enforce sanity upon itself. No traveler would ever succeed in rewriting the past, because space-time would quietly erase the attempt before it began. Perhaps the universe forbids loops in time. If Hawking was right, then time is self-consistent, unchangeable in its essence. It can bend, stretch, and twist, but it cannot turn back on itself. The flow of causality remains intact, protected by the laws that shape it. This doesn't make the universe less magical. It makes it coherent. Even in its wildest structures, nature maintains a certain discipline. Time's arrow may wobble, but it never reverses. The wormhole remains a bridge, not a circle. Quantum effects might destroy the tunnel at the first paradox. The tiniest fluctuations of quantum energy could unravel the geometry the moment a paradox threatens to form. Radiation would surge, curvature would spike, and the wormhole's throat would collapse. It's as if the universe detects contradictions and reacts instantly, closing the door before logic can break. This self-correcting behavior turns physics into philosophy. Maybe the cosmos itself is conscious of coherence, unwilling to let meaning fragment into chaos. Every paradox becomes a brief spark, extinguished for the sake of continuity. Yet the dream persists. Despite these warnings, humanity continues to imagine. The thought of stepping outside time's current is too intoxicating to abandon. We build time. Machines in fiction, in mathematics, in dreams. We explore loops not to escape reality, but to understand it. The wormhole, as a model, endures, not as a blueprint for travel, but as a metaphor for reflection. Each generation of physicists inherits the same question, not is it possible, but what does time really mean? The dream survives because curiosity does. Time machines built from geometry, not gears. Unlike the mechanical fantasies of early science fiction, the real time machines of physics are made not of metal and motion, but of mathematics. They exist in the bending of space-time, the precise dance of curvature and energy. In this view, engineering becomes artistry, sculpting the shape of reality itself. If such a structure could ever be built, it would not whir or hum. It would simply exist, silent and perfect, a doorway carved into the grammar of the universe. A cosmic hourglass turned sideways. Visualize time as an hourglass, sand flowing from one chamber to another. A wormhole turns that hourglass on its side. The sand no longer falls downward. It loops between the bulbs, endlessly circulating. What once marked the passage of time becomes a spatial bridge. The grains are moments, cycling through the same continuum again and again. It's a hauntingly beautiful image, time ceasing to flow and instead folding, eternity captured within the quiet curve of geometry, a door to what was, or what might be. The wormhole, reimagined as a time machine, offers a doorway to both memory and prophecy. One mouth opens to the past, one to the future. Between them lies the present, the instant of crossing. Standing in that threshold would mean standing between versions of yourself. Who you were, who you are, and who you will become. It's not a technological fantasy, but a philosophical truth. Every choice, every thought, is a small wormhole connecting the moments that define us. The question isn't can we, but should we? The temptation of time travel carries moral weight. To witness history is one thing. To alter it, another. What responsibilities would come with such power? Could knowledge of the future destroy the meaning of the present? Physics gives us permission to imagine, but not always to act. The wormhole, as time machine, becomes a mirror of ethics, a test of whether humanity can resist the urge to play with causality. Sometimes, wisdom lies not in invention, but restraint. To travel through time may mean to step outside meaning. If you could exist at multiple points in time simultaneously, cause and consequence would lose order. Memory would become prediction, and identity would blur. You wouldn't experience life, you'd observe it, all at once. The narrative of being, which gives events their purpose, would dissolve. In escaping time, you might lose the very thing that makes time precious, its flow. Perhaps the reason we live moment to moment is not limitation, but mercy. Yet curiosity keeps the door ajar. Even knowing the dangers, we keep peeking through the crack. The possibility of time travel fascinates us because it reflects our deepest longing to understand what we've lost and to glimpse what awaits. Whether through science, memory, or imagination, we are always traveling through time in small ways. We revisit, we anticipate, we dream. The wormhole simply magnifies that instinct into geometry. The future may be unreachable, but curiosity itself is a kind of motion, always moving forward. Every ticking second is already a small wormhole forward. We don't need machinery to travel through time. We do it constantly. Each heartbeat carries us into the future, one infinitesimal step at a time. Between one tick and the next, reality folds, and we emerge anew. In that sense, the flow of time is a wormhole, smooth, continuous, effortless. Every second connects to the next through an invisible bridge called now. The lesson, perhaps, is that we're already time travelers, just slower than we dream. A black hole pulls everything inward. A black hole is gravity at its most absolute. It is the point where space folds in on itself so tightly that not even light can escape. Every particle, every beam of radiation, every trace of time that crosses its event horizon is drawn inward, forever hidden. To approach a black hole is to move toward stillness, a silence so perfect that even the laws of physics seem to vanish within it. Yet that inward pull, that hunger of the cosmos, is also a kind of order, a reminder that even chaos has symmetry. A white hole, if it exists, pushes everything out. Where a black hole consumes, a white hole would expel. It would be the mirror opposite. A region of space-time from which matter and light emerge, but into which nothing can enter. Imagine an explosion frozen in reverse, time running backward, energy flowing outward instead of in. No white hole has ever been observed, but the equations of relativity allow them as natural complements to black holes. One devours, the other creates. Together, they form a cosmic duality. Destruction and birth entwined in the same geometry. A wormhole could link the two. Einstein's mathematics hints that a black hole and a white hole might be connected through a tunnel, a wormhole, joining their singularities. To fall into a black hole might mean to emerge from a white one somewhere else, sometime else. The idea unites opposites, absorption and emission, darkness and radiance. End and beginning. It's a bridge that transforms collapse into creation, suggesting that the universe may recycle its own energy through hidden pathways that no observer has yet seen. Matter falls into the black hole and exits the white. In this model, what vanishes beyond a black hole's horizon doesn't disappear. It reappears, transformed. The information encoded in every atom, every photon, travels through the tunnel of space-time and bursts outward from a white hole's mouth. It's as if the universe swallows experience on one side and breathes it out on the other. No law of physics is truly broken. Matter is neither created nor destroyed. It simply moves, unseen, through the folds of a larger reality. Such structures are called Einstein-Rosen bridges. These theoretical connections, the union of black and white holes, are known as Einstein-Rosen bridges, after the 1935 paper that first described them. They are the original wormholes, conceived long before science fiction gave them color and motion. In those equations, space-time itself behaves like a living thing, folding to connect what should be separate, whether real or not. The bridges embody the universe's hidden symmetry. Every collapse has an opening. Every fall has a return. They might connect distant galaxies. If stable versions of these bridges could exist, they might serve as shortcuts across vast cosmic distances. A black hole in one region could link through space-time to a white hole billions of light years away. Instead of crossing the void at light speed, a traveler, or even a particle could leap through the bridge in an instant. Such connections, if real, would make the universe not an empty expanse, but an intricate web, its farthest corners joined by invisible doors, or even different universes entirely. Some cosmologists take the idea further. If space-time is only one branch of a larger multiverse, then black holes might serve as gateways between them. Falling through one could mean exiting not just elsewhere, but elsewhen, into a universe with different physical constants, different laws, perhaps even different dimensions. Each cosmos could be born from another's collapse, forming an infinite genealogy of worlds. What we call the universe might be one link in an endless chain of cosmic inheritance. No one has seen a white hole, yet the math allows it. Despite decades of observation, No astronomer has found a white hole signature, no object emitting matter without consuming any. Yet the mathematics of relativity places no ban on them. The equations are symmetric. For every solution that describes infall, there exists one that describes outflow. Whether the universe chooses to realize both is another question. Sometimes the beauty of math outpaces the practicality of nature, but beauty often waits to be discovered. Some believe they exist only briefly. Certain models suggest that white holes could form for mere instants, flickering into existence when quantum conditions align, then fading as quickly as they appear. They might be transient bursts of energy, the cosmic equivalent of lightning between dimensions. If so, they would be nearly impossible to detect, their lives measured not in seconds, but in the subatomic shivers of spacetime. Their fleeting nature would fit the universe's rhythm, creation and disappearance as two halves of the same breath. Others think they mark the end of black holes' lives. Stephen Hawking proposed that black holes are not eternal. Over time, they radiate energy, a faint glow known as Hawking radiation. As eons pass, the black hole loses mass, shrinks, and eventually evaporates. Some physicists believe this final stage could transform the black hole into a white hole, a sudden reversal, releasing what was once imprisoned. The process would be slow beyond measure, but in the end, even the most devouring darkness might give back everything it took. When Hawking radiation finishes, a white hole may burst out. In that final instant, when the black hole has radiated away all its mass, its geometry could rebound. The singularity, once a point of collapse, might explode outward, forming a white hole. Matter and information, compressed for trillions of years, would rush outward. In a single burst, it would be the universe's ultimate exhale, a release after infinite pressure. Whether it happens in reality or only in mathematics, the idea transforms death into expansion, reminding us that even endings can shine, releasing the information once trapped. If this rebirth occurs, it may also solve one of physics' greatest puzzles, the black hole information paradox. Quantum theory insists that information cannot be destroyed, while black holes seem to erase it. But if a dying black hole becomes a white hole, the data may simply be delayed, not lost, stored within spacetime's memory and released when the universe is ready. The cosmos keeps its promises, even if it takes eons to fulfill them. Thus, death becomes rebirth, the cosmos recycling itself. Across scales, from stars to atoms, the universe reuses its material endlessly. Supernovas seed galaxies, decay fuels creation, and every collapse gives rise to new form. In the black hole, white hole model, this pattern becomes absolute. Gravity itself becomes the engine of renewal. What falls inward will one day rise again. The cosmos, it seems, wastes nothing, not even darkness. Every ending is compost for another beginning, an infinite cycle of fall and flowering written into the fabric of existence. In loop quantum gravity, black holes bounce instead of vanish. Loop quantum gravity, a theory that merges quantum mechanics with Einstein's relativity, suggests that singularities may not exist at all. Instead of collapsing into infinite density, the core of a black hole could bounce, reversing its collapse into expansion. The immense pressure converts gravity into repulsion, forcing spacetime outward again. The black hole doesn't die. It transforms. What appears to be annihilation from one side is expansion from the other, a heartbeat of geometry, contracting and releasing forever. The bounce becomes a bridge. That rebound, the cosmic bounce, could create a tunnel linking two regions of spacetime. Where we see the event horizon, another universe might see a new dawn. The black hole's collapse is simply half the journey. The other half is the opening elsewhere. The bounce becomes a bridge, connecting not destruction to emptiness, but contraction to creation. In this vision, wormholes are not exceptions, they are natural consequences of how space learns to heal itself. The bridge becomes a wormhole. Once that rebound stabilizes, the geometry forms a continuous passage, a wormhole born from the ashes of collapse. The singularity, once feared as the end of physics, becomes its greatest teacher. Inside its heart, the laws we know bend gracefully into new ones. To cross such a bridge would be to witness creation from within, to see space rebuilding itself in real time. The wormhole ceases to be theory. It becomes evolution, space-time's instinct to connect rather than destroy. Perhaps every black hole hides a new universe inside. Some cosmologists propose that each black hole seeds a new universe beyond its horizon. The moment of collapse in one cosmos becomes the big bang of another. From the outside, we see only the darkness. From within, a burst of light. Each black hole could therefore be a womb, the universe eternally giving birth to itself through gravity's paradoxical grace. If true, our cosmos might be the child of another's death, and our own black holes, gateways for the next generation of worlds. If so, our universe could be inside one too. What if the Big Bang itself was not the beginning, but an emergence, the outflow of a white hole birthed in some parent universe? The expansion we see today could be the exhalation of that earlier collapse, its energy unfurling into our spacetime. The boundaries we call the edge of the universe might simply be the walls of that larger geometry. In this perspective, existence has no absolute start, only transitions, endless crossings between realities nested within one another. What we call the beginning might be someone else's exit. Our entire cosmic history, stars, galaxies, and consciousness might be the aftermath of another civilization's end. Their black hole became our sky. Their silence became our light. The universe may be a continuous chain of transformations, each one inheriting the matter and meaning of the last. The beginning and the end are perspectives, not events, two sides of the same doorway. Somewhere, beyond even this horizon, another world might already be forming from our own eventual fall. Every end, a silent opening. The deeper we look into physics, the more it resembles philosophy. Nothing in nature is truly lost. It only changes form. A star's death becomes the seed of a nebula. A collapse becomes a bridge. Even the blackest holes may be gateways, not graves. The cosmos, vast and patient, recycles itself endlessly, an orchestra of endings that are really beginnings. Perhaps, when everything falls silent at the end of time, it will not be a closing at all, but the soft sound of another universe. Awakening. What if wormholes could be built? For centuries, humanity has dreamed of transcending its limits. First gravity, then distance, then time. What if a civilization far older than ours had already done so? What if wormholes were not natural curiosities, but engineered constructs, bridges carved intentionally into the fabric of spacetime. The idea reshapes everything. Wormholes as architecture, not accident. Such beings wouldn't merely observe the laws of physics. They would use them, sculpting geometry as we sculpt stone, crafting cosmic doorways with equations. Instead of hands, advanced civilizations might manipulate spacetime itself. To a species millions of years ahead, spacetime could be raw material, as malleable as clay. They might weave gravity, bend dimensions, and shape the vacuum into corridors and chambers of energy. Their technologies wouldn't rely on metal or machinery, but on understanding, mastery of geometry at the level where thought and physics merge. They would be artists of curvature, engineers of continuity. To them, distance would be optional, time negotiable, and creation merely another form of travel. They'd need energy equal to stars. To open even a microscopic wormhole, the energy required would rival that of an entire sun. The manipulation of negative energy or exotic matter demands power beyond our comprehension. Yet if a civilization could harness stellar output directly through controlled fusion, quantum singularities, or Dyson-scale energy harvesting, such feats might become routine. They could build gates between galaxies the way we build roads between cities, each powered by the steady burning of captive stars. Exotic matter might be harvested from quantum fields. We can already detect fleeting glimpses of negative energy in quantum experiments. The Casimir effect, the uncertainty of the vacuum. An advanced species might learn to stabilize and amplify these fields, mining the quantum foam itself for the ingredients of geometry. Their refineries would not be factories, but regions of manipulated spacetime, harnessing virtual particles as raw material. For bridges through the void, the universe's deepest fluctuations would become their quarries, its silence their power source. Such beings could cross galaxies in moments. If wormholes could be stabilized, interstellar travel would no longer take millennia. A civilization could traverse millions of light years in seconds, slipping between points of space-time as easily as we step through a doorway. Colonization would become instantaneous, exploration effortless. Their presence could stretch across the cosmos, every world connected through invisible corridors. To them, galaxies would be neighborhoods, the universe a single continuous city of light. Or send messages across time. More subtle than travel is communication. If one mouth of a wormhole experienced time differently than the other, messages could be sent backward or forward through history. To such beings, information itself might be the medium of existence. Time is dialogue. They could observe civilizations rise and fall, receive echoes from their own futures, or see distant epochs with guidance. To us, their signals might appear as strange coincidences, mysterious alignments, or ancient myths whispered across millennia. We might call them gods or engineers. To a civilization that has mastered space-time, the boundary between science and divinity dissolves. Their actions, creating stars, moving worlds, shaping time, would appear miraculous to any lesser observer. Ancient cultures might have glimpsed traces of such forces and called them gods. But perhaps they are not supernatural at all, only natural taken to its ultimate conclusion. The difference between a deity and an engineer may be measured not in essence, but in understanding. Perhaps they already exist, hidden in geometry. If such civilizations endure, they may not live among stars, but within spacetime itself, encoded in its curvature, folded into the structure of reality. Their works might be invisible to us, perceived only as anomalies, strange gravitational lenses, inexplicable bursts of energy, or the quiet alignment of galaxies across billions of light years. What we interpret as nature's symmetry could be the lingering signature of intelligence, patterns left by hands that shaped the cosmos long before we learned to look. Our universe might be their experiment. What if the cosmos itself is a creation, a laboratory, a garden, or a work of art? Perhaps an ancient civilization, having learned to manipulate space-time, initiated a controlled expansion, a Big Bang born from design. They might observe from outside, studying how matter, life, and consciousness evolve under varying physical laws. To them, we would be part of the experiment, our questions echoing the curiosity they once felt. The universe, then, becomes a dialogue between maker and made, observation looping back on itself, or their forgotten passageway. Alternatively, the wormholes we imagine might not be creations still in use, but relics, ancient corridors left behind when their architects moved on or perished. Like abandoned roads reclaimed by nature, these tunnels might drift silently through space-time, untraveled yet intact. We could be living beside their remnants, unaware. Every strange gravitational anomaly might be a door left ajar, a cosmic artifact weathered by eternity, waiting for someone new to find it and wonder who came before. Wormholes could be their highways, cosmic transport routes, to link billions of worlds. The most efficient design would be a network of stabilized wormholes, a galactic transit system powered by controlled curvature. Each wormhole mouth could be anchored to a gravitational node. Like an orbital station, travelers or information could cross from one to another in an instant. Such a network would be invisible from our perspective, appearing only as subtle distortions of starlight. The Milky Way itself might be crisscrossed by such roads, unseen veins of geometry pulsing beneath the stars. Each galaxy a station. If the network spans the cosmos, then every galaxy could serve as a terminal, a nexus of local bridges linking to others across unimaginable distance. Each spiral of stars would be a hub, each cluster a junction. Travel across the universe would feel like movement within a single organism, light flowing through its arteries. The scale becomes irrelevant. Connection replaces distance. What we see as isolated galaxies may, from a higher vantage, be pieces of one immense structure, the living architecture of communication itself. Each star system a node. On smaller scales, wormholes might connect individual star systems. One mouth orbiting a sun, the other anchored in deep intergalactic space. Ships, signals, or even consciousness could flow between them. To us, such alignments might appear as unexplained. Gravitational distortions or bursts of radiation. Cosmic traffic passing quietly through unseen gates. If our solar system were ever linked in this way, Earth might already be part of a network, older than humanity, connected to the stars without knowing it. We, the latecomers, discovering the remains. Our telescopes peer into the night and see patterns, symmetry, structure, the quiet fingerprints of order. Perhaps what we call natural law is simply the residue of design, the scaffolding left by civilizations long gone. Like archaeologists of spacetime, we uncover fragments of a story too vast to read in full. Maybe wormholes are not promises of what we could build, but echoes of what others already did. We are the latecomers, studying the ruins of an ancient geometry. Dyson once said, "If we see order, intelligence may be near." Physicist Freeman Dyson speculated that advanced civilizations might build megastructures around stars to harvest their energy. But his insight reached deeper. Intelligence leaves patterns. Order is the shadow of purpose. If wormholes exist in abundance, arranged with improbable precision, that order might be a clue, evidence not of randomness, but of thought. The cosmos, viewed through this lens, becomes a record of intentions written in gravity, a message encoded not in language, but in symmetry. Wormholes might be signs of such order. Natural wormholes, if they exist, should be rare and unstable. But if we were to detect a network of them, stable, structured, distributed with apparent logic, it would challenge our understanding of nature. The simplest explanation might not be chance, but design. Each wormhole could be a marker, a doorway left deliberately open. To find one would be to find evidence that someone, somewhere, once bent the universe into shape, not through magic, but through mastery. Natural or artificial, who can tell? If we ever discover a wormhole, how could we know whether it is natural or constructed? Both would obey the same laws of physics. Geometry, after all, leaves no signature of authorship. The difference might lie in subtle details. The precision of symmetry, the stability of the field, the elegance of the equations that describe it. Nature is beautiful, but intelligence refines beauty into intent. Perhaps, in the end, the line between natural and artificial is itself an illusion, for consciousness, too, is nature made aware of itself. The universe leaves no labels. Nowhere in the stars is there a plaque saying, "Made by," or "designed on." The cosmos offers no signatures, only patterns. Every galaxy, every nebula, every particle is anonymous, yet perfect. Perhaps that is the ultimate artistry, creation. Without ownership, design without vanity. If ancient builders did craft wormholes, they left no names, no warnings. They trusted geometry to tell their story and silence to preserve it. The universe remembers through form, not inscription. But the geometry might remember. Even without records, spacetime itself holds memory. The curvature of the universe bears the imprint of every force that has ever acted upon it. Every wave, every fluctuation, every tunnel leaves a trace in its structure. In that sense, geometry is history, written not in words, but in warps and weaves. If wormholes were ever made, their echoes still hum through the vacuum, quiet but eternal, waiting for minds sensitive enough to listen. Every equation, a fingerprint of its maker. Mathematics is the only universal language, and physics, its poetry. Each equation that describes a wormhole, a black hole, or a beam of light might be a reflection of something, or someone, that once dreamed it into being. The laws of nature feel discovered, not invented, yet discovery itself might be remembrance. Perhaps when we solve the deepest equations of space-time, we are not learning something new, but recognizing a truth long imprinted in the cosmos, the fingerprints of the first architects, still glowing softly in the dark. A wormhole is not just a path, it's a question. It asks not where we are going, but what it means to move at all. Every bridge implies separation, and every passage suggests the longing to unite. The wormhole, in this sense, is philosophy made visible, a curve in the structure of both reality and thought. When we imagine it, we are not merely speculating about physics. We are articulating a deeper human need, the desire to connect what feels divided, to find wholeness in a universe of fragments. Why must distance exist at all? We measure the world in kilometers and years, but distance might be only a perception, a veil drawn by limited senses. If all of space-time is one continuous whole, perhaps far and near are illusions, distinctions born from perspective. The cosmos doesn't separate itself. We do. Maybe the gaps we see between stars, between minds, between hearts, exist only so that we can learn to cross them, to discover the quiet joy of reaching across the void and finding another presence waiting there. Why does time move forward? The arrow of time feels absolute, past behind, future ahead. But physics hints that the laws of nature work equally well in reverse. So why do we remember yesterday and not tomorrow? Perhaps time's flow is not a property of the universe, but of consciousness, our way of experiencing change. We move forward because we observe forward. A wormhole, curving time upon itself, invites us to question that flow. What if all moments coexist, and now is simply where awareness happens to rest? Perhaps the universe seeks connection. Every law, every force, every motion seems to weave things together. Gravity binds galaxies. Electromagnetism ties atoms. Even quantum entanglement links particles across infinity. The cosmos could have chosen chaos, isolation, but instead it chose relationships. Wormholes, real or imagined, reflect that impulse. They are not accidents. They are the universe's way of expressing its unity. If existence had a will, perhaps it would be this: to connect endlessly in every possible way. Every mind that wonders is already crossing one. When you ask a question about the stars, you are already moving through a bridge from not knowing to knowing, from doubt to wonder. Thought itself is a kind of wormhole, a curvature in consciousness that links 2 points of understanding. The moment curiosity awakens, you've already traveled. Knowledge doesn't happen across distance, it happens through it. Every question is a tunnel of imagination, every answer a light waiting at its far end. Between ignorance and understanding, there is a passage every learner must take, a narrow throat where confusion tightens and patience becomes gravity. On one side lies darkness, on the other, clarity. That tunnel is as real as any wormhole. It is built of persistence, curiosity, and humility. When we finally emerge, what we find is not certainty, but expansion, the realization that knowing is endless, and that every new understanding only opens another passage ahead. Between fear and awe, all great discoveries begin in uncertainty. The same trembling that makes us afraid also opens the heart to wonder. Standing before the unknown, we feel both impulses at once: retreat and reach. The wormhole represents that moment. Fears collapse into fascination. We step through not because we are certain, but because awe pulls stronger than hesitation. In the balance between terror and curiosity, humanity finds its courage. In dreams, we travel through inner wormholes. Each night, as consciousness dissolves into sleep, the mind folds inward. Memories, desires, and symbols intertwine, creating corridors that connect distant parts of the self. We drift through landscapes that obey no physical law, yet feel more real than waking life. These are our private wormholes, tunnels through the psyche, linking what we are with what we might become. In dreaming, we experience space-time as thought, fluid, nonlinear, and luminous. From memory to imagination. Memory bends the past. Imagination bends the future. Between them lies the present, the wormhole of awareness through which both flow. We travel constantly along that invisible path, carrying fragments of who we were into visions of who we may be. The brain, like space-time, is curved by experience. Every thought loops through countless associations, connecting moments separated by years. We are living wormholes, consciousness traveling between what has been and what could be. Consciousness itself might be a bridge. Perhaps awareness is not. Something in the universe, but something connecting it. Each act of perception links observer and observed, creating a channel between mind and matter. In that sense, consciousness may function like a wormhole, binding distant aspects of reality into a single experience. When we become aware, we unify what was separate, the external world and the inner self, the seen and the seer. Reality, in turn, becomes complete through that union. Thought bends time, just as gravity bends space. When you remember, you curve time backward. When you anticipate, you curve it forward. The mind moves freely across the continuum, unbound by clocks. In that sense, thought is a gravitational force, invisible, yet capable of reshaping the landscape of perception. We live inside these mental geometries, our emotions pulling us toward or away from moments like bodies orbiting stars. To think deeply is to travel, to follow the curvature of meaning through the fabric of being. Every realization is a shortcut through confusion. Understanding doesn't always arrive gradually. Sometimes it strikes like light bending suddenly into focus. One moment, chaos, the next, clarity. In that instant, the mind creates a wormhole of comprehension, leaping across uncertainty into insight. It's not that the distance between not knowing and knowing disappeared, it folded. Every aha moment is a microcosmic traversal, a reminder that discovery is not about covering ground, but finding the right curve. Science and spirituality both seek these bridges. One uses mathematics, the other meditation, but both reach toward the same mystery, connection. The scientist curves space with equations. The mystic curves awareness with silence. Each, in their own way, attempts to bridge the seen and the unseen, the known and the ineffable. Wormholes are their shared symbol, pathways through limitation. Perhaps every telescope and every prayer points toward the same thing, a desire to touch what lies beyond reach. The microcosm and macrocosm reflect each other. From atoms to galaxies, the same patterns repeat: orbit, attraction, connection. The curve of an electron's path mirrors the arc of planets. The spiral of galaxies echoes the twist of DNA. If wormholes bind the universe on the largest scale, maybe thoughts and emotions bind it on the smallest. We are scaled versions of the cosmos, each of us containing the geometry of infinity, tiny reflections of the same laws that bend the stars. The wormhole becomes a metaphor for empathy. To understand another being is to bridge two separate worlds. Empathy folds distance, not spatial, but emotional. When you truly listen, You create a tunnel between minds, allowing light to pass both ways. It's a silent exchange, a gentle curvature of the heart that connects you to someone else's inner universe. Wormholes remind us that connection doesn't always require movement. Sometimes it only requires attention, for seeing beyond oneself. The greatest discoveries happen when perspective expands beyond the self, when we look at existence not from within our boundaries, but from beyond them. To see oneself as part of a larger whole is to step through a different kind of wormhole, the passage from isolation to belonging. In that moment, individuality doesn't disappear, it integrates. The ego doesn't die. It learns to orbit something larger than itself. To love is to bend the distance between souls. Love, in its purest form, defies separation. It curves the emotional universe, drawing two consciousnesses into proximity despite the space between them. Like gravity, it needs no medium. It simply acts. When you love, you distort time. Moments together feel infinite, and absences feel endless. In the geometry of feeling, affection is the force that keeps the cosmos of human hearts from scattering into cold isolation. Love is our most natural wormhole. To forgive is to fold time and start anew. Forgiveness is a temporal act, a way of rewriting the past without changing it. It bends the arrow of time inward, closing the loop of resentment. When you forgive, you reconnect two moments that pain once tore apart, who you were and who you are now. The act itself is a passage, not forgetting, but transcending. In the architecture of emotion, forgiveness is the bridge where healing meets memory, where the future can finally return to greet the past. The universe mirrors our desire to connect. Every human longing seems to echo a cosmic principle. Our search for understanding mirrors gravity's pull. Our creativity mirrors the universe's expansion. The wormhole, too, reflects something inward. Our refusal to accept division as final. Perhaps reality is participatory, responding to the consciousness within it. When we imagine bridges, the universe listens. When we dream of unity, space bends just a little closer. Perhaps wormholes exist because we dream them. Maybe the act of imagining connection is itself creative, shaping possibility through awareness. The universe, vast and ancient, may generate structures that mirror its own introspection. Wormholes might exist not despite our wonder, but because of it, as the cosmos responding to its own curiosity through us. Every dream, every equation, every whisper of longing folds reality inward, one thought at a time. Perhaps we are not just observers of the universe's bridges, we are the bridges, dreaming each other into being. If wormholes exist, they may link every moment to every other. Imagine a universe where every instant is connected, where time is not a line, but a vast, folded web. Each moment touches every other, past and future braided together in silent dialogue. In such a cosmos, wormholes are not exceptions, but expressions, threads of continuity woven through the fabric of existence. To move through time would not be to travel, but simply to remember the way home through eternity's folds. Nothing is truly separate. Every particle influences every other, no matter how distant. Every atom in your body once burned in the heart of a star. The illusion of separateness exists only in perception. Beneath it lies unity, a single field humming through all. That is, wormholes, real or imagined, remind us of that truth, that everything touches everything else, always, even when we cannot see the bridge. Space is one great, folded whole. From the smallest quantum fluctuation to the farthest galaxy, space-time stretches as a single, continuous sheet. Its folds create gravity, its waves carry light, its curves define reality itself. In that sense, there are no borders, only contours. A wormhole is simply one of those folds made visible, a place where the universe gently brushes against itself and whispers, "I am whole." The universe could be talking to itself through light. Photons travel endlessly, carrying messages between distant stars. Every ray of light that reaches your eyes has crossed billions of years to arrive, an ancient sentence in a language of brilliance. Perhaps the cosmos communicates through this light, each photon a syllable in an infinite monologue. When we look at the night sky, we might be witnessing the universe in conversation with itself, echoes passing through the wormholes of time, or dreaming of itself through gravity. Gravity is more than force, it is memory. Every mass bends space-time, and space-time responds, creating motion, a dialogue of attraction. The universe may dream through this tension, its curves the shapes of thought. Every orbit, every wave, every wormhole could be part of a deeper self-reflection, the cosmos folding inward to contemplate its own existence, as consciousness does in silence. Wormholes might be memory, space-time, remembering its shape. If space can bend, it can also recall. A wormhole could be a kind of remembrance, a trace of how the universe once connected distant regions. Geometry becomes nostalgia, space-time revisiting its own configurations. Just as the human mind recalls a moment and feels it return, the universe may revisit its forms through curvature, reliving connections that once were. Every wormhole, then, is not invention but recollection. Each black hole, a letter in a cosmic language. The universe writes itself through structure. Black holes are its punctuation marks, pauses, breaths, commas in the sentence of being. Each one holds meaning, compressing energy and time into a symbol of transformation. Perhaps the cosmos speaks through these shapes, spelling out an eternal story that only geometry can tell. The letters are vast, but the message is simple. To exist is to change. Each wormhole, a sentence between realities. If black holes are letters, then wormholes are phrases, connections that give context and meaning. They link separate worlds, just as language links thought. The universe, in this metaphor, is writing itself into coherence, folding words of matter into sentences of motion. To discover a wormhole would be to read a line of that great story, one written not in ink, but in light and curvature, each bridge of verse in the poem of creation. When you look at the stars, you're reading those letters. Every pinpoint of light above you is a fragment of that text, an ancient phrase from the universe's autobiography. To gaze upward is to read history in photons, stories written across eons. The constellations may be myths to us, but to the cosmos they are syntax, grammar arranged in the quiet rhythm of gravity and glow. You are already literate in that language. You feel its meaning even when words fail. When you sleep, you travel between them. Dreams may be our small wormholes, journeys through memory and imagination that ignore linear time. When the body rests, the mind drifts through corridors of thought, visiting places long gone or not yet born. In those moments, distance dissolves, and we become travelers in a private cosmos. Sleep is the universe's gentlest invitation to practice eternity. The universe expands, folds, breathes. Like a living being, the cosmos inhales and exhales, expanding, contracting, cycling. Galaxies drift apart, only to be drawn back by gravity's embrace. Even emptiness pulses. This rhythm, too, may be the heartbeat of wormholes opening and closing, the respiration of creation itself. Existence is not static but tidal, a breathing of being that never ceases. And so do we. Our lungs mirror that same rhythm. Every breath in is expansion. Every breath out, release. We are miniature universes performing the same cosmic dance. The pulse in your wrist echoes the motion of galaxies, contraction and expansion, holding and letting go. To breathe consciously is to harmonize with the pattern that sustains everything. You are not separate from the cosmos. You are one of its smaller ways of breathing. There may be no true elsewhere. Every there you can imagine is still part of the same whole. The universe has no outside. It curves endlessly into itself. Even the word beyond loses meaning. There is only continuity, depth without edge. When we dream of faraway worlds, we are simply exploring deeper layers of here, the same reality folded into new forms. Only layers of here. Space isn't stacked by distance, but by perception. Each layer reveals a new version of presence, molecular, celestial, spiritual. From the grain of sand to the swirl of galaxies, everything exists in nested scales of here-ness. The wormhole becomes a way of peeling those layers back, discovering that there is simply another face of now. We are always home, even when we wander. The end of one path is the beginning of another. Every journey through space or mind eventually circles back. What feels like conclusion is only transition, the next curve in the infinite line. The stars die so that new ones may form. Civilizations fade so that memory can spark again. The universe has no full stop, only commas, pauses before continuation. Each ending is just another door disguised as silence. What we call distance may just be unawareness. Perhaps nothing is ever truly far. We simply haven't learned to perceive the link. Awareness collapses space. To understand is to touch. When you grasp a truth, you are instantly closer to it, no matter how vast the gulf. Maybe wormholes don't erase distance, but awaken perception, showing us that separation was always a misunderstanding, that closeness was never lost, only unnoticed. What we call separation may just be sleep. Sleep is the soft veil between awareness and totality. When we forget our connection to the whole, we drift into a kind of cosmic slumber, dreaming of isolation, of selves and others, of here and there. Awakening, then, is not moving closer, but remembering that we were never apart. Wormholes are the universe's gentle nudge, whispering, "Wake up. Everything you seek is already within you." An awakening, a return through the same bridge. To awaken is to travel backward through the tunnel, retracing the path that once led outward. The bridge never disappeared. We simply forgot its presence. Each realization, each moment of clarity, is a crossing from illusion into recognition. What lies on the other side of enlightenment is not a new world, but the old one, finally seen as whole. The wormhole is both real and symbolic. It exists in equations, and in emotion, in space-time, and in story. It is the shape of gravity and the metaphor of love, the scientist's hypothesis and the dreamer's prayer. The wormhole endures because it speaks to every level of being, the physical, the mental, the spiritual. It is both laboratory and myth, proof that understanding and wonder are two sides of the same cosmic bridge. And perhaps, in every breath between thoughts, we cross one. Between inhalation and exhalation, between one heartbeat and the next, there is a pause, a silence that feels infinite. In that stillness, awareness shifts, folds inward, connects. Perhaps that is our smallest wormhole. The moment of presence where mind and universe meet. You have crossed countless such bridges without knowing. Through wonder, through love, through rest. And as you close your eyes now, another one opens. The bridge between waking and dreaming, carrying you gently home. You've traveled far tonight, through equations and imagination, through the folds of space-time and the quiet corridors of thought. You've crossed from the smallest quantum tremor to the breath of galaxies, and in doing so, you've crossed something deeper still, the space between wonder and peace. Maybe the wormhole was never out there at all. Maybe it was always within you. The bridge between curiosity and calm, between knowing and simply being. As the stars drift slowly overhead, let their light remind you that connection is everywhere. Every atom in your body, every beam of starlight, every dream that flickers behind your eyelids, all are part of one unbroken story, whispering across time. So now just breathe. Let go of the day's gravity. Feel yourself floating, weightless in the soft current of the cosmos. There's nothing left to reach, nowhere left to go. Only the quiet rhythm of the universe breathing with you. And as you drift toward sleep, imagine one last bridge, a gentle wormhole opening not into another galaxy, but into rest itself. Step through. Let the stars dim. Let the silence expand. You are home now. Always were. Always will be. Good night, traveler.